So if we start with the circle equation, that looks like this section is called the conic unit. So you guys started with circles and parabolas, but the general circle equation, if we throw in kind of some variables, the standard equation looks like this. Okay. Where r minus h, so the h value and the k value, these are the center points. So our center is h comma k, so we use that to put it back into the standard form. And then this is our radius. So we do need to know the radius to be able to put it in the equation, but notice that it's radius squared. So we'll keep those things in mind when we go through the practice problems. So I'll go through most of them. Some of them I will skip because they're a little redundant. But if we start with the very first one, you have, and the directions were to graph this. So here we had x squared plus y minus 2 squared equals 4. So if we identify a few parts of that equation, start here with the center. If you notice there's no parentheses around the x, so that means that the x coordinate of the center is 0. So our center is at the point 0, 2. Again, we take the opposite of what's in the parentheses. So for this particular circle, this is where our center would be at 0, 2. And then our radius is squared in the equation, so we have to do the square root. So we would do the square root of 4 to tell us that our radius is 2. So when we graph this, we're going to first graph the center, and this is true for all of the circles that we'll graph. So I'll just erase this here, and we'll throw the graph at the top. So the graph so we know that for sure our center is at 0, 2. So our center is going to be right here on the y-axis. Let me put this in a different color, make it easier to see. And then we're just going to go 2 in each direction. So we'll go 2 to the right, we'll go 2 units to the left, we'll go 2 units up, and 2 units down. So this generally would be our circle. Okay. For the next one, same idea. I switched it up a little bit. So the equation is x minus 1 squared plus y squared equals 16. So again, we can find our center. Our center is going to be 1, comma 0. Again, we don't have a parentheses for the y, so the y coordinate of the center will be 0. We take the opposite of what's in here for the x, so we take a positive 1. We're going to need to do the square root of 16, so the radius would be 4. Okay? So if we plot that, so we know that our center is at 1, 0. So this time our center is here. Our center is here. And we're going to go out 4 in each direction. So we'd have 1 dot here. We'd have 1 dot straight up from here. There we go. And then we'd have 1 dot here and 1 dot here. So this would be our circle. Okay. All right, so then if we do 3 and 4, these are the same ideas for graphing these circles. So if I erase this circle. All right, so for number 3, we have the equation x squared plus y squared equals 36. So for this one, notice we have no sets of parentheses. So that just means our center is right at the origin at 0, 0. And then our radius would be 6, the square root of 36. So we would just have our center, or the center of the circle right at the origin here, and then we're going out 6 in each direction. So our circle would be kind of something like that. Okay, cool. And then for the last one, the same idea. Now I'm not going to graph that one. It's very similar to all the other ones that we graphed. The center would be, so I will write the equation and help you identify the parts, but it's very simple to graph these circle equations. So we have x minus 4 squared plus y minus 4 squared equals 9. So the center would be the opposite of each of these. The center would be at 4, 4. And then the radius would be 3. So we would go 3 each direction. 3 to the right from the center, 3 to the left from the center, 3 up and 3 down. And then draw our circle that way. So that's graphing circles. Graphing circles are relatively straightforward. For 5 and 6, they give us the equation in a different form. We want to get it into standard form for the circle. So we'll walk through how to do that. So they give us for number 5, they give us x squared plus y squared minus 6x minus 6x minus 6y plus 17 equals 0. Okay. Now what we want to do here for these is we'll have to end up completing the squares, just a way for us to get this in terms of parentheses. Our end goal, we want to be like something like this: x minus something plus y minus something equals r squared. That's kind of what we're trying to get to. We just have to get into that point first. First step would be to group your x's together. So I'm just going to group these x's together and then group the y's together. And this guy has to get moved over to the other side. So I'm just going to rewrite this to be x squared minus 6x plus something. We'll have to figure out what that something is in a second. Plus y squared minus 6y plus something equals negative 17. Now these blanks that we're going to fill in are going to do whatever numbers we put in each of these spaces. We have to also make sure we do it to the right side of the equation to be consistent. We can't just change one side of the equation without equally changing the other side. So to find what number goes here, we take this number. This is our b value. Remember this from when you guys did the factoring review chapter? That's the b value. We're going to take the b value, we're going to divide it by 2, and then whatever answer we get, we're going to square it. So negative 6 divided by 2 is negative 3. We square that, we get 9. So a 9 would go here. Likewise, this would be the same exact thing. If we do negative 6 divided by 2, we get negative 3. Negative 3 squared is 9. We'd also put a 9 there. Now, like we said, whatever we do to one side, we have to also do to the other. So if we added a 9 for this parenthesis, we need to add a 9 to this negative 17. If we add a 9 for that parenthesis, we need to add another 9 for that side over there. Okay. Now, the next thing that we would do after we figure those pieces out, erase this, is we would want to figure out how we can factor each of these parentheses. So we'd want two numbers that multiply to 9 that somehow add or subtract to get us negative 6. Well, that would be x minus 3 and x minus 3. Well, we could write that as x minus 3 squared. And this is the preferred way that we like to write it so we can get it into standard form. Plus, same idea here, this would be y minus 3, or we could write it as y minus 3 squared. Okay? And then over here, negative 17 plus 18, that's going to give us a positive 1. So all of this is equal to 1. So we actually already have now the circle in standard form, where the center is going to be the opposite of each of these. So the center would be at 3, 3. And the radius is the square root of 1, which is just 1. Okay? So we'll do the exact same thing for the next one that's in standard form as well. So for the next equation, you have x squared So one thing I'm going to do, I'm going to skip and group the x's together to start with to eliminate a step. So I'm going to do x squared minus 4x, and then we know we're going to have to do plus something. And then the rest of what they give us is y squared plus 6y. And then that 2, it was a minus 2, but we need to move it over to the other side. Plus something here, and then if that negative 2, if we move it over, is going to become a positive 2. Okay, so now from here, we want to complete the square. We want to figure out what has to go in each of those spaces. So if we do negative 4 divided by 2 is negative 2. negative 2 squared is 4. So we put a 4 there, and that means we would also have to add a 4 here on that side. So we do the same thing here. 6 divided by 2, and we take that middle number of the b value, equals 3. 3 squared is 9. We put a 9 here, we put a 9 here. Okay. So then from there, we're just going to go back and factor to figure out how we can better group these into factors. Well, two things that multiply to 4 but add or subtract to give us negative 4. Well, that'd be x minus 2 and x minus 2. Or we can just say x minus 2 squared. Okay, and then plus two things that multiply to 9 but also add or subtract to get us 6 would be y plus 3 and y plus 3, which is just y plus 3 squared. And then if we add up these guys here, we have 2 plus 4 plus 9. That's going to be 15. This equals 15. And it's fine that this is not a perfect square. That's fine. We're just putting this equation in standard form. But if the follow-up question were to identify the center for this one would be at 2, negative 3. And the radius would be the square root of 15. So usually this radius can be a whole number, but in this case, because this 15 is not a perfect square, the radius is the square root of 15, which is about a little bit less than 4, so like 3.8 or so. All right, so then if we move on to number 7, we're given kind of different characteristics of the circle, and we're asked to figure out the equation in standard form for the circle. So for number 7, we have the center is negative 4, negative 3, and the radius is 5. Okay, so if we're doing the center, that just means we have to do x plus 4 squared, we do the opposite of this, plus y plus 3 squared equals, now it always equals the radius squared. If the radius is 5, that means that it equals 25. And that would be our equation. So pretty simple equation. All right, for number 8, so this was number 7. For number 8, they tell us that the center is 2, negative 5, and the diameter is 8. So they try to be a little bit tricky. Be careful because we can only use the radius. So if the diameter is 8, we really want to convert that to the radius. That means the radius is 4. Okay, and that's really the more important piece that we want to use is that the radius is 4. So then from there, we can write our equation. So if the center is the x coordinate of the center is 2, that means we do a x minus 2 squared, and then plus y plus 5 squared. And then the radius we said was 4. Diameter was 8, but we only need half of that number. So the radius is 4. We're going to put that in as 16, 4 squared. And that would be that equation. So let's look at 9 and 10. So there's a little bit of a variation on this. So I'm actually going to do number 10 first, and then we'll go back and do number 9. So if we do 10 first, they tell us that the center is negative 614, and the area is 16 pi. Okay, so if we start with this area part first, because the center we already have that information, that will help us to write the equation relatively easily. But area, if we remember the area equation, that is pi r squared. So if our area equation, which is pi r squared, if that's supposedly equal to 16 pi, okay, we can divide both sides by pi. So our pi's would cancel. So we'd find out that r squared is equal to 16. So that means that r is equal to 4. Okay? So this is just a fancy way of letting them tell us that the radius is 4. So from there, we have all we need to write the equation. So we know the center would be x plus 6 squared, y minus 14 squared equals 16, or 4 squared, because the radius was 4. So also be careful too, in case they decide to give you their circumference. Let's say on a question they gave you the center and their circumference. The circumference equation is 2 pi r. So let's say for this particular example, let's say instead of giving you the area, I gave you the circumference, and I told you that the circumference was equal to 10 pi. Okay? So all you would do for something like that is take your circumference equation, which is 2 pi r, 2 pi the radius, set that equal to 10 pi, and solve for r. So that would tell us we can divide both sides by pi. So pi's would cancel. So we get 2r equals 10. So r would have to be 5. Okay? And then from there you could do your center equation. So it'd still be the same information here, but the radius would have been 25. And that's if they would have given you the circumference instead of the area. All right, so let's get back and go to number 9. So for number 9, we have the diameter, and they really give us just the endpoints of the diameter. So the diameter starts at 9, -1, and it stops at 1, -3, or 9, -15. Okay, so one way to look at this, which may be a little bit easier, we can always use the distance formula. That's just another formula to try to keep track of those. So I'll show you a different route that may be a little more helpful on the test if you can't remember the distance formula. So if we were to just kind of plot where these points are, kind of roughly, if I plot this one, 9 is going to be, let's call this 9, let's call this -15 down here. So we have this point here at 9, -15. Okay. And this one's at 1, -3, so let's call this somewhere, if this is 1, let's call this -3. So this is 1, let's call this -3. So we got this point here at 1, -3. One thing that we can do is create a triangle, a right triangle. So we can figure out how far down did we have to go and how far across did we have to go to get to that point. The good thing about that is to create a right triangle, and that's going to help us just do Pythagorean theorem to find this distance. That's really what we want to know, is that distance. So we went down, if we started at -3, we went to -15, we went down -12. If we started at 1 on the x and we went all the way over to where it was not in the x, that means we went a distance of 8. So to find this distance, we could do Pythagorean theorem. So it'd be -12 squared plus 8 squared equals, let's call this would be our diameter, let's call this d squared. So we got -12 squared plus 8 squared equals d squared. So this would be 144 plus 64 equals d squared. So that would give us 308 or 208. 208 equals d squared. So d is equal to the square root of 208 if we do square root. Now that's the diameter, we just want the radius. So the radius would be half of this amount. So the radius would just be, if we do the square root of 208, I don't have a calculator with me, but just to approximate, that's between like 17 and 18. So let's call this about, for the diameter, and you could always find the exact value on your calculator, but let's say that this is approximately 7, let's say 14. It's actually going to be between 14 and 15. So let's just say it's about 14. Then that just means we're going to cut this in half. So that means that the radius that we're actually going to use is 7, is about 7. Okay. So if the radius is 7, that's helpful. The other thing that we know about the diameter is right in the middle of the diameter, in the midpoint of the diameter, is the center. The center is for the diameter. If we just found that this radius is about 7, this would be about 7. The center is going to be right in the middle. We need to find the midpoint between those 2 points. Okay? So one way to find the midpoint without really needing a formula is if we went down 12 all the way and over 8, we just need to go half of those amounts. So if we go down 6, half of 12, so we go down 6, that would get us to -9. And then if we go over 4, we don't have to go over 8, we go half of that. If we go over 4, that would get us to what? 5. So our center is at -9, 5. So again to kind of recap, instead of going all the way down 12, I just went halfway down because this point is halfway in between those two. And instead of going all the way across 8, like what we did to get to that point originally, I just went halfway across. I just went 4 across. So our center is at negative 9, 5. We found that our radius is at 7. So to write our equation, we would have, here, our equation would be x plus 9 squared y minus 5 squared equals roughly about 49. Now again, I kind of rounded the number because we had the square root of 208, but that would roughly be about the equation. This may end up being a decimal, but you can double check that with your calculator. Okay, so then that's all of the circles. Now we'll move on to parabola stuff. So let's first kind of look at the standard form for parabolas. There's 4 different orientations for parabolas that we deal with. We have it where it's the regular parabola kind of going up like what we're used to. And that would be x squared equals y, something with y. And to be a little more accurate, I'll write the full standard equation. So that would be x minus h squared equals 4p y minus k. Okay? So the x's and the h is just the center or the vertex. Normally the vertex is at the origin, but we can shift it. Okay? This p is helpful to have us find what we call the focus and the directrix, because the focus is always the point inside of the parabola, and the directrix is always the line right also on the outside. The important thing is that this distance from the center to the directrix is equal to p, just like this distance from the focus to the vertex is also equal to p. Okay, so knowing what this p value is important to find the focus and the directrix. But if it's opening up, it's x squared minus h squared equals 4p y minus k. It can also be opening down. It would just be a negative in front of this guy here. Okay? If we look at the other orientation, where we can be going left or right. So if we have something like that, that one is actually y minus k, because k always goes with the y. Y minus k squared equals 4p x minus h. So just be careful with this notation. The vertex is flipped. So this is actually the y part of the vertex. This would be the x part. So if you get it, don't grab this as the x and that is your y coordinate of the vertex. This is the x coordinate of your vertex. That's the y. So as an example, let's say you had y minus 4 squared equals 4x plus 1. A lot of people would forget the y's and the x's are switched. So what they would do is say, oh, the vertex is 4, negative 1. We don't want to do that. The 4 is the y, the x is the negative 1. So really it should be negative 1, 4. So just be careful if it's flipped where you have the y first. Okay, so if it's y squared and positive, it should be opening to the right. If this were y squared and there was a negative here, it'd be opening this way to the left. Okay, just like up here, we normally open up, but if there were a negative in front of this, then we would be opening down. Okay, but we'll go through those. So just kind of as a recap. So if we look at number 11, they give us the equation and they want us to graph it. So we'll just graph a few of these. A lot of these are the same type of way to graph these, just like with circles. Parabolas are just a little slightly confusing, more confusing than circles because you have the foci and the directrix to deal with. So if we have negative x plus 2 equals y plus 10 squared. Okay, so it's y squared, so we know it's going to be either opening left or right. The negative tells us it's opening to the left. So we should be, just to keep in mind, we should have a parabola opening that way to the left. Okay, another thing to keep in mind, you can find the vertex. The vertex is the opposite of this, so negative 2, negative 10. So if we sketch this, our vertex is like somewhere here, right? We also know it's going to be opening, we can sketch it kind of opening this way. Now to find the exact points, you could always plug in different values for x and y, or for x. So you could plug in what is it when x is negative 3 to figure out what points those are to kind of do it in, but we can just kind of sketch it. From there, we can find the focus and the directrix. Now remember, there usually is a 4p, something like that, in front of this equation. But we just have a negative 1. So there's always a built-in 4 in these equations, We just have a negative 1 in front of our equation. So we have to ask ourselves, how did we go from negative 4p, to just a negative 1? What was our p value? So that means if we were to solve this, that p must have been 1/4. So to kind of recap, there was always a 4 built into our generic equation, but we don't have that 4 anymore. We have a 1. So that tells us that the p had to be 1/4 to get rid of the 4 that should have been here. So what does that mean? So that means that we're going to go from the vertex, we're going to go 1/4 in and 1/4 out. Now the 1/4 in, that's going to be your focus. And then the 1/4 out, we're going to create this into a line. So this would be our directrix. Right? Now, because this is going to the left, our directrix is x equals some number. Now, if we could figure out exactly what that number is, we know that the vertex is -2, -10. So this vertex is -2, -10. And we're going 1/4 in each direction. So this would be -2 and 1/4 for the x, because we're going -2 that way, still -10 for the y. This directrix, we're now going 1/4 back out. So from -2, we're actually adding a positive 1/4. So this would be at -1.75, or at -1 3/4. So just to kind of recap, once you find your p-value, you're taking that and you're adding it to only one part of your vertex. In this case, because the focus needs to be inside of the parabola, we're adding that p-value to only the x portion of the vertex. To go find in here to find the focus, and then we're basically subtracting it to go back to find the directrix. Right? So then if we we'll do number 12. So number 12 and 13 are very similar. This is where you have it in a very weird form. You have to get it in standard form. You have to complete the square. So I'm just going to do number 12. The same exact thing would be used for number 13. The only difference is number 13 has the y squared instead of the x squared, but it's the same steps. So this is number 12. Okay. So it's x squared plus 10x minus 4y plus 1 equals 0. Okay, so in this case, before when we were doing with circles, we kept the variables on one side and moved the numbers on the other side. In this case, we're going to move the y over, because the x squared and the x are going to stay on this side. Anything that's not squared is going to get moved on the other side. So I'm going to rewrite this to be x squared plus 10x plus something, we'll figure out in a second, equals 4y minus 1. So I just took all of this and moved it over there. Okay. So then from there, we can do our b value thing. We're going to do b divided by 2, and we're going to square it. So we're going to do 10 divided by 2, which is 5. Then we're going to square it and get 25, and that's going to go there. But remember, whatever we do on one side, we have to also do on the other side. So we have to add in a 25 on the right side to be consistent. Now we're going to go back and we're going to factor the left. So we're going to get x plus 5 times x plus 5, which we can write as x plus 5 squared. Okay, equals, now if we simplify this, the -1 and the 25 we can combine together to get 4y plus 24. Okay. And we're actually not done. We want to have actually the x and the y both in a set of parentheses. We notice over here, these two terms have 4 in common. So we can pull out a 4 and we get y plus 6. So this would be the final equation for that parabola. This is x squared and it's positive. So it would be opening up. Our vertex would be at -5, -6. So it would be somewhere like here. So the vertex would be somewhere here and it would be opening up. So something similar to that. The p value, if we look here, there's always a 4 built into the equation. We still have the 4. So that tells us the p was 1. So we're just going to go 1 unit in and 1 unit out. So if this was -5, if the vertex was -5, -6, and we're going 1 unit up and 1 unit down for the focus and the directrix, that means our focus is going to be still the same x value, but now we're going up 1 on the y, it's going to be -5. And our directrix, we're going down 1 would be y equals -7. So we were at -6, we go down 1 to -7. It's a horizontal line, so it's y equals. So that would be how we would graph that equation. But this would be your final answer as to getting it into standard form. Okay? And 13 is the exact same way. The only difference is you have your y squared instead of the x squared, but you would move the 4x and the 7 over to the other side. Okay? Same thing is true for 14. You would keep the x squared and the 6x there. You'd move the 2y and the 13 over to the other side. Okay, so then if we look at the last, I'll do 15, 17, and 18. 16 is very similar. We'll do 15, 17, and 18. Okay, so for number 15. So for 15, we have the vertex is 5, 7. And the focus is 5, 2. Okay, so I usually recommend to plot these just to get a feel for which way the graph is going. Okay, so if the vertex is at 5, 7, the vertex is here. The focus is at 5, 2. It's here, and the focus always has to be inside of the parabola. So the only way for the focus to be inside the parabola is if the parabola is opening down. So that focus is inside. So that tells us if it's opening down, we're dealing with x squared. So it should be x minus something squared equals 4p y minus k. Okay. The only thing we're missing is that we need to have the negative, because if it's going down, it should have a big negative. It should be a -4, like that. Okay, so we just need to fill in these guys, these variables. So first we start with the vertex. We know that this is going to be x minus 5 squared equals -4 something y minus 2. Okay, because we just take the opposite, y minus 7. We just take the opposite of these vertices points. And so to figure out the p-value, let's look at the distance. The p-value is technically the distance that we traveled from the vertex to the focus. So if we notice, this was at 5, 7, this one's at 5, 2. So the only thing that changed was the y value. We actually changed the y value by 5. So this distance is 5. Just like if we were to do the directrix would be out here somewhere, another distance of 5 above it. So that tells us that p has to be 5. Remember, p is the distance from the vertex to the focus, or the distance from the vertex to the directrix. So that distance was 5. That means our p-value is 5. So to finish out our equation, it'd be x minus 5 squared equals -20 y minus 7. And that'd be the final equation. All right, so let's skip to 17, and then we'll finish up with 18. So for 17, we have the vertex is 6, -3. And then the directrix is y equals -1. So again, I would recommend kind of plotting these just to figure out which direction we're going. So 6, -3 puts us here. But then we have y equals -1, which is right here. The directrix always needs to be on the outside of the parabola, so that tells us the parabola has to be opening down again. Okay? So that tells us we're dealing with x minus something squared equals -4 something times the 4, or p, y minus something squared. Okay? So we can fill in these blanks here and here, because those are the points of the vertices. So x minus 6 and x plus 3. Okay, now we need to figure out the p-value. So this was 6, -3, and this is at -1. If we were to find that point right directly above the vertex, that'd be at 6, -1. So we could see that we went a distance of 2 to go from the vertex to the directrix, which means we'd have to go another distance of 2 to find the focus. So that tells us the p-value. P is 2. So the final equation would be x minus 6 squared equals -8 y plus 3 squared. All right, and then if we finish up with number 18, this time they give us the focus and they give us the directrix, and they want us to figure out the equation. So this is now number 18. The focus is 7, -5. And the directrix they tell us is y equals 3. So again, I'm just going to quickly plot this to figure out which way the graph is going. Just because sometimes by looking at just the coordinate points, you're not entirely sure whether it's opening up, down, left, right. So it's always a good idea to just kind of sketch it and use what you know to figure out which way it should be going. So the focus is at 1, 2, 3, 4, 5, 6, 7, -5. So the focus is here. And remember, focus always has to be on the inside of the parabola. And the directrix is at y equals 3. So all the way up here is our directrix. Directrix is always on the outside of the parabola. So the only way for the focus to be on the inside and the directrix to be the outside is that parabola would have to be going down again. Because if it were going up, let's say you proposed that it was going like this, it's going to cross that directrix, which it shouldn't do. So then you might say, well, what if we did it left and right? Couldn't it go left and right? Well, if we did it left and right, let's say we said it was going this way, the directrix always has to be exactly behind the vertex. So this actually tells us that our vertex is somewhere in between here. And that's exactly true. Remember that p-value is the same distance from the vertex to the line as it is from the vertex to the focus? That means our center is somewhere in the middle here. So if this is 7, -5, I'm just going to plot the point, put a big point right here, right on the directrix that's exactly right above the focus. That point would have been 7, 3. So we can figure out that there's actually 8 units difference in between the focus and the directrix. That means 4, right halfway in between, is where the vertex should be. So if we just were to go up 4, that would put us right at the vertex. So if we go up 4, we actually get here at 7, -1. So our vertex is at 7, -1. So to kind of recap what I did there, I looked at the distance from the directrix to the focus. I saw that was 8 units, and I cut it in half. And so you could either look at it as, if I go 4 units from here to here, where do I end up? Or you could say, if I start at the focus and I go up 4 units, where do I end up? Either way, remember the vertex should be equidistant from the line and the focus. So that tells us the vertex is here, and our parabola is doing something like that. Okay? And once we figured out that we were, from the focus, we were up 4 to get to the vertex, that tells us that our p-value is also 4. So we actually have everything that we need. So if we plug in the equation, so I'm going to erase it up here. We know that since it's going down, it should be x minus something squared equals -4p. Well, p we said was 4. Y minus something. Okay, so it would be x minus, we said our vertex was 7 for the x coordinate, so x minus 7. P-value we said was 4, that's 4 units from the vertex to the directrix, or 4 units from the vertex to the focus. And then the y part of the vertex is -1, so we'll just go +1 there. So our final equation would be x minus 7 squared equals -16 y plus 1. And that would be it. So number 16 is very similar to what we just did. So you can practice that just to see if you have that concept down. But remember, for these guys, when you're given foci and directrix and different coordinate points, plot it and figure out which way the graph goes, and then go from there.